Hi everybody. We're going to find the critical numbers for f, find the open interval where f is increasing or decreasing, and apply the derivative test to identify our relative extremum. So the first thing I'm going to do is take the derivative of f, and this is going to be 1, and if I rewrite this is x to the negative 1, so this is going to be minus x to the negative 2. So this is going to equal 1 minus 1 over x squared. And to have the same common denominator, this would be x squared minus 1 over x squared. So that would be 1. So if you look at the numerator, and we're setting this to 0, I can rewrite this as x minus 1 times x plus 1 equals 0. So my critical numbers are at x equals 1 and x equals negative 1 for the numerator. We also have a point of discontinuity at x equals 0. So we're going to consider that a critical number as well. And we're going to test all of this on the next slide. So I had x equals negative 1, 0, and 1. These were our two critical numbers. This was our point of discontinuity because you can't divide by 0. So I'm going to make my intervals from negative infinity to negative 1. Then I'm going to go from negative 1 to 0. And then from 0 to 1. And then from 1 to infinity. Now, my derivative was, let's see, x squared minus 1 over x squared. So, for smaller numbers here, if I put in like negative 2 in here, that's going to square out. And this is going to be positive. So the sign here is going to be positive. Same thing here. Oops, sorry. Whoops. If I put in, say, 2 into my function for x, so you'd have 2 squared minus 1 over 2 squared. That's positive. So I'm doing this one. These two, I'm going to have to probably use fractions. So let's try 0 to negative 1. Let's do negative 1/2. So if you have negative 1/2, what's going to happen is you're going to get negative 1/2 squared is 1/4 minus 1 over 1/4. Well, this is going to end up being negative, and the denominator is positive. So a negative over a positive is going to be negative. So the sign is negative. And the same thing's going to happen here because we have the square for this interval. So that's this one's also going to be negative. All right. Therefore, this is increasing from negative infinity to negative 1. It's increasing here. And you can just put plus, plus. And these are decreasing, so I'm going to put minus, minus. So it's increasing, then decreasing again, then increasing. Something like that. Okay. Now we have to find our, let's see, relative min and max if we have it. So we're plugging in our endpoints, which is negative 1 and 1, because we don't have to plug in this one, because we're going to plug in this one and this one. And we're plugging into our original equation. So I'm plugging in f of negative 1, and you plug in negative 1, you're going to get negative 2. And when you plug in 1, you're going to get 2. So our points are negative 1, negative 2, and 1, comma 2. Therefore, our maximum is going to be at negative 1, negative 2, because you can see here, this is where it's increasing. It's increasing first, all right? And then our minimum is going to be here, because you can see here, this is where it would start increasing again. Okay? Thank you. Have a nice day. Bye-bye.